Very good evening, sir. How are you? I'm also fine. Very good evening, Niharika. How are you, Niharika? Okay. Okay, then so let's continue with the class. Okay, so first of all, wishing you good evening, everyone. So it's going to be our third session on the aldehyde, ketone, and carboxylic acid. Okay, so let me just quickly give you a brief of the previous class, what we already discussed. So the last topic was there, that is the double H. Okay, so there we're discussing about the double H. So double H is what? That is the diisobutyl, okay, aluminum hydroxide there. So this is a double H. Now, what is the important point we discussed there? That the double H, whether you are having arsen, okay, that this is arsen, or maybe we are having a kind of ester. Okay, so this is like very famous for this, either the arsen group is there, or like our COCR group, like you can say it's a ester there. If it is present there, so obviously we are going to use and one more, that RCOCl. Okay, in all three cases, if I'm using double H, so what we are end up there simply, that is we are end up with the aldehyde there. Okay, so we are basically end up with the aldehyde. So this is the point which we already covered in the previous class. So let's continue with the double H. Let's discuss more point about the double H. So now listen, that in this case, what is the important point there? That for the double H do not reduce. Okay, it's do not reduce, don't reduce double bond. Okay, so generally do not attack on a carbon carbon double bond. For example, how? Let's see a kind of question type. Okay, let's see the example there. So how about the example? If we are talking about the example here, like is it going to react or not? So observe this. Okay, this is a kind of question. For example, let's suppose this is a CH3. Okay, this is a CH and a double bond CH and CH2 and CH2 and CN. Okay, for example, this is given. Okay, and in this case I'm using a double H. Okay, this is my double H. Okay, now what is happening? Observe this, that this double bond will remain intact. It means this is not going to change. No, it's not going to change. Then what we are getting there, that simply this is a CH3 and a CH2 and a CH2, sorry, double bond have to be there. So look at this, the double bond is there, CH, and then we are going to continue about this. Okay, and then this CH2, one carbon, okay. And this is COH is there. So look at this, that if you're observing something, the double bond, look at the position of a double bond. This double bond same, okay. So what is the change here? Look at the change is the CN converted into the aldehyde there. Okay, so this is all for the double H. Now let's move further. Let's discuss more about a different kind of reaction. If you remember in the previous class, we just started with if you are having a nitrile, okay. So if you are having a nitrile, and with the help of nitrile, we are discussing about how to form a aldehyde there. Right? So in this discussion, we just discuss about some kind of reducing agent like lithium aluminum hydride or sodium borohydride and double H. And the double H or one more derivative, when with the aluminium one, that OB Bu group is connected there, right? So these two are the lithium derivative or the lithium aluminum hydride derivative, which one reducing the power of the lithium aluminum hydroxide so that we are end up with the aldehyde only. Okay, so this is the simple case for the nitrile here. So let's continue. Okay, question part is easy. Let's see. Next point. Okay, so in the same trend that if you're having a nitrile and I want to convert it to the aldehyde, the next reaction is going to be the naming reaction and important obvious. So what is the name for the reaction? So let's discuss about that is the Stephens reaction there. Okay, it's a Stephen reaction. So what is the Stephen reaction? In this case, again, mechanism is not important. For which reaction the mechanism is important, I will explain to you there, okay? So what is the Stephen reaction? That in this case, again, you are using some RCN, okay? That's nitrile part, and then SnCl2. Okay, be noted that for a naming reaction, we can't change the condition. Okay, otherwise we can do, but this is the only case. So SnCl2 plus HCl, you can say these two are the reason for the that Stephens reaction. SN2 plus HCl is there. Okay, when you are adding this, what we are getting simply that we are end up with the that RCOH is there. Okay, so it means we are getting a simply that is the aldehyde only. Okay, so this is all for the Stephens reaction there. Now, just answer the question. This is a kind of question for you. Okay, so this is the question. My question to you, if I'm having a CHC in there, okay, and I want that is a CHCHO. So now you can apply the previous class or today's class as well. Like which reagent? Like what is the question mark you want to prefer here? Which reagent I can use? Scratching. Wait, I will wait for a while, Siva. Just let me know is the same problem still. Please confirm. Shiva, is this okay now? Or this still the problem with the voice? Okay, then I'm assuming. Anyway, answer the question which reagent we can use here. Okay then, so please answer the question. Which reagent we can use for this question mark? Okay, then I will tell you. So in this case, what is this question mark? Question mark can be double H as we just discussed. So you can use double H, or we just discuss about one more reagent that you can use SnCl2 plus HCl is there. Okay, so this is a very good reducing agent that SnCl2 and the HCl is there. So it's a Stephen reaction. So you can use any reagent there. Let's move further. Now let's talk about the next reaction here. Now, let me just give you kind of brief. We discuss about only aldehyde part, if you remember. And in only aldehyde part, we already covered acyl chloride part. There we discuss about Rosamond reaction and that part. Okay, so acid chloride part. And the second one we just discuss about the nitrile part. And the last one is going to be the hydrocarbon. So it means you can say now we are going to discuss about the preparation of aldehyde from the hydrocarbons. Okay, so in the hydrocarbon part, let's continue. Okay, so in the hydrocarbon part, let me just write all the method one by one. So what is the method number one? Method number one, that is oxidation of methyl benzene. Oxidation of methyl benzene. I hope you know the meaning of the methyl benzene. That is toluene is known as a methyl benzene. So this is a step number one. Or the step number two, that is the side chain chlorination. Anyone, can you just tell me the reason for a side chain chlorination of methyl benzene? This topic we already covered in a haloalkane chapter, if you remember. If you're not able to recall something, it means that you're not revising the thing. And the last one is the Getterman-Koch reaction. Okay, so let's just discuss about the first one, that is oxidation of the methyl benzene. Okay, in this case there is a two more important naming reaction have to be there. Okay, so let's continue. Cl2uv, yes Shiva, you're right. Okay, if you're using Cl2uv, so instead of the given chlorine going to connect at the ortho or para position, the thing connected on a benzyl position. So you are right, Shiva. Okay then, so let's continue about the methyl benzene topic. So in this case, let's talk about that by chromyl chloride. Okay, so the method number one, we are discussing about oxidation of methyl benzene. Okay, and the method number one, that from chromyl chloride. It's a from chromyl chloride there. So let's see how. In this case, same, like you can use which kind of reagent we are using. So reagent is what, since the name is what, chromyl chloride, so we're using a chromium one, CrO2Cl2. This is a reagent number one. Okay, because in this topic we're going to discuss about two part there. So it's a CrO2Cl2 there. If you remember that the salt analysis, this is a chromyl chloride test for the detection of chlorine. Salt analysis, the same reagent we already used there, chromyl chloride. Okay then, and the CS2 and hydronium ion. It means some hydrolysis kind of thing have to be there. Okay, so this is the reason. And the second point, that how about the reactant or a substrate? Like if we are discussing about a substrate is the methyl benzene. Substrate is going to be the methyl benzene, or you can say the toluene. The point number three, that which kind of product we are getting. So product is obvious, that aldehyde, benzaldehyde in short. Okay, so in this case, we are going to get a benzyl layer. Don't say ma'am, you changes the position. Okay, so there is a no space. Otherwise, the position will remain same. Okay, same benzene. Okay, without any substituent. So every position is same there. So now let's start with this. In this case, everything is sorted, but what is the important, that intermediate there? So look at this. That first of all, it's a methyl benzene. Okay, it's our methyl benzene. And now in this case, let me just write the reagent here, CrO2, Cl2, and CS2, and hydronium ion. Okay, so that one hydrogen will remain same. First of all, let's discuss about the complete reaction. Then we are going to discuss about the shortcut as well. So look at this, that this is the carbon and this hydrogen will maintain. It means two hydrogens replace. So like let's see, the two hydrogen replaced by what? Let me tell you the kind of mechanism, although it's not important, that this is the chromium. Let's just use the different color. Okay, so this is my chromium, and chromium connected with two oxygen like this. Okay, and then two chlorine connected like this. This is the CrO2Cl2 there. Okay, so it means what is happening, that this chromium, okay, this chromium or this carbon simply combine with this chromium here. Okay, and this chlorine leave the molecule. Okay, this leave the molecule, and this is how the bond open up. And whatever be the hydrogen is there, okay, the same hydrogen, this hydrogen going to connect here. Okay, just try to understand, mechanism is not important. Okay, so what is the important point here? You can say that this carbon, okay, important is what the thing I want to connect now. So in this case, that this is connected with oxygen. Okay, it's important that it is going to connect with the oxygen part, and then the next one is going to be the chromium. Okay, O, chromium, and then OH. One portion is OH there. Okay, and one portion Cl2 Cl2 part will make same there. So let me just raise this, that you can say that how the bond open up. Just try to imagine this bond open up, then there's a negative charge written, and this negative charge simply connected here. Okay, and then like again, this bond is going to connect with the OH there. It's not important, just important is what this point. So first of all, we are using first time one hydrogen replace. The same you can go one more the same thing like O. Important because we are going to discuss about the same thing for a Étard reaction. So it's important. Try to understand. Then again, chromium and then chlorine part will maintain and then this OH. Do you know? So many times this question already asked in a PYQ that which kind of intermediate formed between this product and a reactant there. This is really important. Carbon is connected with oxygen, then chromium, two chlorine still connected there, and OH have to be there. And this is simple, easy now. Then what is going to happen? Whatever be the OH bond, okay? So look at this. This is the OH bond. After this step, hydrolysis step. So what is the use? That after the hydrolysis, that this chromium part release, and we are getting that it's simple, a kind of benzene and that carbon hydrogen and OH and OH. This thing we I guess we discussed so many times that on a same carbon geminal diol is never ever stable. So quickly what is happening? The water molecule remove there. So once the water molecule remove, what we are end up there? That we are end up with the benzaldehyde. Okay, so it's very important kind of method for the preparation of benzaldehyde. You know how the question asks some method is given to and the question asks in which we are getting a benzaldehyde. Okay, so it's little bit important there. This is all for the chromium part. Now, uh, let's see that a kind of next one that is from chromic oxide. The first one is the chromic chloride, and the second one is going to be the chromic oxide. Let me just back again toward the mechanism. Yeah, here. So, in this case, in the oxidation of methyl benzene, the step number one, we are using chromyl chloride. Okay. Similarly, in this one, the next method is going to be the chromic oxide. Okay, so the first one, chromic chloride, the same like reagent and everything. I'll look at the reaction there. Now let's talk about the method number two. That is with the help of the chromium, chromic oxide. So by chromic oxide, by chromic oxide. Okay. So now, in this case, same which kind of reagent we are using. Let me just write the reagent again. So how about the reagent? So the reagent, obviously the topic name is the chromic chloride. So this is a CrO3. And important, in this case, we are using that this thing. Okay, what is it? It's acetic anhydride. Let me just write it properly. What is it? It's a CO, okay, and connected by O and a COCH3. So it's a acetic anhydride. Okay, this given thing is what? It's a acetic anhydride. Okay, so this is the reason here. And like temperature, if you have to mention, 273 and 283 Kelvin. Listen, if the same equation came into the board exam, so be noted everyone. If you are not able to recall the temperature, you can omit. Okay, but for the naming reaction or for like these kind of reaction, we can't use the wrong temperature. So better to omit if you are not able to remember the temperature in the exam time. Okay, so important. It's the point number one. And the point number two, that it's a hydrolysis. So I hope this point is clear, like what is going to happen in a hydrolysis. Again, we are starting with the methyl benzene. Let me just write that is the methyl benzene. And the same thing we are using CrO3 and CH3CO and it's a twice an O there, okay? So what we're getting, same the intermediate is important. So what is the point here? That the same one, that this is a carbon. Carbon is connected with hydrogen, okay, and then this is CO. Okay, now unhydride part is going to combine. So it's a O, CO, CH3. Okay, similarly, that is one O, CO, CH3 there. So if you have to compare with the previous one, let me just back again. So observe this, the same oxygen, but there the chromium, but in the next one, look at this. Here we're having acetic anhydride one. The step number two is same, that after the hydrolysis, this is going to release And what we are end up there, we are end up again that the same thing, that it's a benzene and a carbon connected with the 2OH group like this and a hydrogen there. And then we are going to follow the hydrolysis, and then we are end up with the benzaldehyde. Okay, so this is a step number two by the chromic oxide. Okay, now mm, like every time no need to observe, like every time don't represent this. Important is what, if you are having a toluene, just simply add the chromium oxide to the chromic chloride, we are end up with the benzaldehyde. But yes, intermediate is important because I already told you this intermediate ask so many times. Put star here, important. Like what about the intermediate in this given reaction there, okay? So this is all for the reaction. Let me just check any kind of question for this. No, there is a. And wait, I missed this. Okay, and it's a Étard reaction. Okay, I'm sorry. I forget about to write. It's a Étard reaction. This is a naming reaction. It's a Étard reaction. So two naming reaction done now. That is, one is the Stephenson reaction and the second one is the Étard reaction. So it's a Étard reaction. Okay, and if you're observing the reason, so let me just highlight here. It's a Étard reaction. Okay, this is all for the Étard reaction. This is all for the chromyl chloride. And this is all for the chromium oxide there. So now, okay. Now let's talk about the next method, that from side chain chlorination. Side chain chlorination of methylbenzene again, okay? So then, in this case, what is happening there? Again, the same one, that first of all we are using the CH3, then we are using a Cl2 in the presence of light. In this case, the intermediate is the free radical. So if the free radical is the intermediate, so definitely that is the benzylic position have to be preferable one, right? So it means that in this reaction, if you have to go further, the chlorine is going to combine with the CH3 part. So as this is a, like you can say, the free radical mechanism, one like chain initiation propagation there. So in this case, what is the important point? That maybe more than one chlorine can be connected there. So this is how two chlorine connected here. The step number two, that again hydrolysis step. So again, if you are using a hydrolysis step, what we are getting there, that the chlorine is replaced by the OH there. Same ditto, same mechanism, OH. And again, if you are end up with the two OH there, at the end we are getting benzaldehyde. Okay, so this is like right now, all method is just for the benzaldehyde only. Okay, this is for the side chain chlorination. And the last one, and really important, the mechanism is the Getterman-Koch reaction. So be noted, it's a Getterman-Koch reaction. It's not Getterman reaction. That the if you remember the chapter haloalkane arene alkane one, there we discuss about two method, that is Sandmeyer, and then the next one is the Getterman. So yeah, next first of all, answer this question: what is the difference between Sandmeyer and a Getterman reaction? Yes, please. Till then, I have to write the reaction. What is the difference between the Sandmeyer reaction and the Getterman reaction there? Although the first name is same like Getterman, but it's the Scotch reaction. It's important for this one. We are going to discuss about the mechanism as well. Like this question asks so many times, what is this? What is this Getterman Koch reaction? So basically, it's a kind of, okay, it's a kind of electrophilic substitution reaction. I have to repeat one more time. This question asked so many times, that is a Getterman Koch reaction is which kind of reaction? So it's a electrophilic substitution reaction. I will tell you why. Okay. So since if this is a electrophilic substitution reaction, it means we are going to follow those three step generation. Okay. Okay. See, it's a different scientist. Okay. These two are the different scientists, Shiva. Okay. This is a different scientist. Okay, so what we're discussing that electrophilic substitution reaction. So in this case, it means we're going to use the three step. The step number one, the generation of electrophile. The step number two, the formation of rhenium ion. The step number three, that removal of the proton. But at least we know what is this, right? Which kind of reagent we are going to use or which kind of substrate we are using. So right now, we are discussing about the preparation by methyl benzene, okay? But in the Getterman-Koch reaction, we have to start with the benzene. It means if let's suppose we are talking about the substrate part there, so if I am using substrate, so what about the substrate there? That benzene. It's important that it's benzene there. Okay then. Next reagent. So how about the reagent? Reagent is very much important. CO or HCl. That is a it's not cobalt. It's a CuHCl. It means the carbon double bond, and then one is the dative bond. This is a CO and HCl there. Okay. So let me first write the general reaction. Then we are going to discuss with the mechanism part here. So let's talk about the general reaction. So how about the general reaction there? General reaction wise, that this is a kind of benzene, okay, and then we're using CO and HCl. So like if you're observing something in this case, it's look like that COH fit here, right? That the H part and a CO part and HCl part here. But okay, sorted, this is the reaction, but how to deal with the reaction, like how the mechanism of the reaction, the mechanism is also the important one. So the step number one, we are using the COHCl, and a step number two, in the same step we are using anhydrous. And for this one, you will tell me why I'm using anhydrous AlCl3. You can use any Lewis acid, as you know that if you're using electrophilic substitution reaction, so we're requiring a kind of Lewis acid, right? But why? Recall the same. The answer will be the same. Yes, please, anyone? Or should I explain then? Okay, not an issue. Okay, so let's see that how the thing is going to work here. Let's discuss about the mechanism of the Getterman-Koch reaction. Okay, so how about the mechanism there? In this case, step number one, that is a generation of electrophile. Generation of electrophile. So how? That basically you will be having a CO, carbon triple bond oxygen, and then HCl is also there. Okay, so in this case, what is happening? That this CO attack on a hydrogen there. Okay, so means what we're getting, that is a CO oxygen bond opener, okay, and a hydrogen part connected here. But if you're observing something, that just because of this, now if you're observing the carbon there, carbon valence is 3 only, so that's why positive charge. Chlorine will be like, I'm negatively charged, so why not I can connect with you, right? So it means that chlorine part simply connected here. So basically this is the step number one, that HCl connected with the CO there, and we are getting this. But no, then the name of the step is the electrophilic, the generation of the electrophile. But then how to approach? Now the our AlCl3 came into the picture, the same use of the AlCl3. AlCl3 be like chlorine, just come with me. Okay, so what is happening in this case? This aluminium has a vacant orbit, right? So it's attack on a chlorine. So once it's attack on a chlorine, what we are getting there, that first of all, there is a generation of AlCl4 negative, okay, and then it's a hydrogen and a carbon and a double sorry, wait, that is a double bond and oxygen there. It means now our positive charge is ready, right? So this is the thing, that an electrophile is ready. So the next question asked from this topic, what is the electrophile in a Getterman Koch reaction? So it's going to be the Hc positive oxygen there. Okay, after the generation of this, the next step is very simple. That is a step number two, that benzene. This is a simple benzene. Benzene is going to connect with this, that hydrogen, carbon, positive charge, double bond. Okay, so benzene connect here. What we are getting? Okay, like if you to go with this, you can undergo the resonance part as well. Like this is how carbon, triple bond oxygen, and positive charge here. Okay, so both step are okay. Now see this. So there is a like carbon connected here, oxygen connected here, and a hydrogen connected here. And just because of the extra attack of this H, there is a generation of the positive charge, right? I hope you remember that this positive charge is going to delocalize. What is it? It's a arhenium ion. It's a arhenium ion or the sigma complexes if you remember. Okay, so now this is ready. The step number three, that again the removal of the proton there. So what is this? That in this case, like hydrogen is there and a positive charge, hydrogen is there, and this is the positively charged. And then chlorine, the aluminium chloride one again come, like Al, Cl3 is already connected, chlorine is the extra part. Chlorine attack on this hydrogen. Okay, wait, chlorine attack on this hydrogen. Okay, this is how the bond break, and what we are getting, that benzene is restored again. So it means this is how the mechanism look like. So it's a kind of electrophilic substitution kind of mechanism. This mechanism is simple. Okay, this is all for the Gatorman reaction there. Now you are done. Any problem with any step or any topic till now, let me know. Okay, because now we are going to solve the question part. This is all for the preparation of aldehyde only. Let me just quickly give you a brief. In the aldehyde only preparation, we discuss about the diable H topic. Okay, or we are using some derivative of lithium as well. Stephen's reaction, in which we are using SnCl2, or it's still there. We are using nitride. And in the same class, we discuss about the Étard reaction or the chromium oxide there. And the last one is the Gatorman-Koch reaction. This is all for the reaction of aldehyde only. Okay then. Now, let's discuss about some question there. Okay, this is a question for you. So you have to identify, like, out of all the method, in which method basically we are end up with that aldehyde only. Okay, so let me just write the question for you first of all. Question is this, that among the following, the number of electron that produce, wait, it's going to be the reaction, right? Wait. Number of reaction. If you already familiar with the question, then again you have to solve that product benzaldehyde. So you have to identify in which case we are getting the product as a benzaldehyde. Okay. So the option number A, you can say these are different kind of step. So like the number of step which you have to identify. H2PD BSO4. This is the option number one. Like no, I that the choice number. Okay. And the C. Wait, I will change the position of the video. Okay, like just identify among these options, okay? Because no space, if I have to move the next slide, maybe you're not able to identify, okay? Yes, please answer the question. And it's an advanced question, okay? Easy one, right? Yes, please. Among the following, the number of reaction that produce benzaldehyde only. And better if you tell me the name of the reaction as well. Okay, Shiva. Yes, of course. The first one is the Rosenmund reaction, right? And the B is that dibyl H1, right? Of course. And then C is the Étard reaction, and E is the that which what is the name of the reaction we just discussed? Keter-Mennenkotz reaction, okay? And F is the Friedel-Crafts acylation, right? Which was the Stephens one? Which one is the Stephen? In the Stephen one, we're using that SnCl2, okay, Shiva, and plus HCl there. So right now, not even a single reaction is the Stephens one. Okay. Anyway, let me explain the question for you. So in this case, look at this. It is going to give yes. The name of the reaction, Rosamond reaction. Benzaldehyde, yes. In this case, we just discussed it's a Itard reaction. Okay, so yes. And B is this dibyl H, you know the basic use of the dibyl H. Dibyl H is going to convert a nitrile into the aldehyde part. And the D1 that the side chain chlorination we discussed. So obviously it's a in this case we are getting a benzaldehyde. Option number E that the Getterman reaction. Yes, of course in this case we are getting a benzaldehyde. And in the F1 it's a that acetylation is there. So let me just explain the F option for you, okay? So if you're observing the F option, that it's a kind of benzene and we are using CH and a CO and Cl there. It's a Friedel-Crafts acylation, right? So in this case, what we are getting basically that the chlorine or this part is connected. So it's not aldehyde or a benzaldehyde, it's our ketone. Okay? It's ketone there. So hence, out of all the option, only the last option is the wrong there. Okay, it's wrong. It means the correct answer for this question is going to be the how many correct answer? 1, 2, 3, 4, and 5. So 5 is the correct answer. So very good, Shiva. And okay, how to approach it are cyclochlorine Gutterman. Very good. Okay. And every time when you're solving the PYQ, try to understand like which kind of naming relation given to us, right? Okay, so that's it. This is all for the question. Let's just move further. This is all for the reaction of aldehyde only. Okay. One more question. Okay. This time easy. Okay. You know what is the problem? If the same question will be in exam, so many of you going to omit this question, but it's easy. Like what I'm using. You know, sometime like problem is what is tolerant? Tolerant is nothing. It's just a simply the solvent is there. Okay, so tolerant is not an issue, and this is the temperature for the tolerant that minus 78 degrees Celsius. It means you can see the kind of cold reaction. And the second one, that is the step number two, is the hydrolysis there. Okay, then you have to identify what is this, like what will be the product for this given reaction. So let me just write some option for you. Okay. So option number A, B, option number C. Now the interesting part start, because you know what is the problem. We know what is double H. But like actually how it is going to work is the important part of the question. Or the option number D. Yes, please. Now answer this. Which of the following is the correct answer, okay? It's a lectum. Yeah, you can say it's a kind of lectum. But you know, lectum has a proper, you can say there's a some part of the lectum, but it's not proper. Yes, please answer the question now. What is the correct answer for the question? Let me just highlight. This part is the lectum. Hmm. Yes, what is the correct answer? I guess it's not difficult question. Okay, Dashika, not an issue. I will tell you actually how the reaction is going to work. Okay, let me tell you the general approach. Okay, so how the diol is really going to work. Okay, so first of all, you will be having this CH3, okay, CO, and a OCH3 part. Right? So basically, this is the thing we are having esters when we are using a diol H. So let's suppose if I'm using the diol H. So what is the function? Diol H simply that break the bond. In this case, the bond break from here. I guess you're not observing this thing earlier that in this case, what is the product we are getting? Let me just again move to the slide where I just explain all the thing. Observe this, right? So Mike, like maybe you have to ask this question there, but no one asked about this question that if you're observing the like R is there, R is the common point. Okay, like CU is okay, like CUH is there. But the point is what? That how about this R? There or in this one, I never ever give you the idea about this R. But like actually how it is going to work. So let's just back again the question part here. Do you know how it is going to work there? That if this is going to break, if this is going to break, what does diol H? Diol H be like, I am a hydrogen donor. I am a reducing agent. So the one hydrogen is given here and the one more hydrogen is given here. It means in this case we are getting simply that is a two kind of product. One is the aldehyde part and the one is the alcohol part. Okay, so now next time be noted if I'm using ester, so it means that one become alcohol and one become the aldehyde. So let's just back again. So in this case, that if you're observing again, some of you be like, "Mom, just break the bond from here." No, 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 no. It can't be happen. Otherwise, it's become CH group. Okay, like if you're observing this, it's a CH group. No, diol H specialty is what? It is going to convert the ester into the aldehyde, not the acid part. Okay, so it means this is the wrong way to proceed with the question. Then should we have to break this bond? Of course, you can go. If I'm breaking this bond, if you have to break this bond, so this portion like one hydrogen simply transfer in, one hydrogen simply transfer here. What we are getting? Look at this, OH and a CO there. Okay, why not this is the correct answer? Because first of all, observe we already covered the double bond is not affected by the double H. Double bond reduce. Not correct. Double bond maintain. Okay, but in this case, like how? No, it's not correct again. So only what is the correct answer for this given question is that option number D. Okay, so I hope this question is clear for everyone, but still any problem if you are having, let me know. Okay, so the correct answer for this question is the option number D. Okay, Dishika, is this question clear now or everyone? Is this question clear? Like how to approach the question for the double H? Okay, that's it. This is all for the aldehyde only part. Now let's start with the ketone only part. Okay. So as we discussed in the previous class, that the preparation, that aldehyde only, then ketone only, and then both. So now the next topic is going to be the preparation of ketone only. So again, some reaction is waiting for you. So let's discuss about the reaction of ketone, or better to read the preparation of ketone. Preparation of ketone only. So same, some naming reaction and some important reaction. Let's just start with the reaction number one, that from acyl. The the method number one from acyl chloride. I hope you know what is the meaning of acyl chloride. Acyl chloride means this kind of group, like acid chloride you can say. And in this case, I am using that R2CD. CD is what? Cadmium. Okay, you know, zinc, cadmium, mercury. So that's CD this is. It is going to work like a Grignard reagent. It means you can say this one has a partial positive charge and R got the partial negative charge. So this is like a kind of organometallic compound. Okay then, so it's a cadmium and an R2. Right now we're just discussing the general reaction, okay? Let me just write general because again for this one we are going to discuss the mechanism. So it's a general reaction. What do we are end up? Obviously the ketone there. Let's just see a kind of, let's say this is R dash. R dash. So in this case means how the reaction going to proceed simply that R will maintain and this O. So it means this R dash is going to combine here. Okay, so this is the ketone only. Okay, sorted. But how the mechanism, how this reaction is going to work? So let's just discuss about the mechanism part as well. So let's discuss about the mechanism, how it is going to work. So first of all, you will be having some R, CO, and one more thing. What is the point to be noted here? That it's a R2CD, means one cadmium or the one this kind of R2CD combined with two molecule, because you know one R dash is combined with this, so that's why we are using two time, because R2 present with the cadmium. I hope you're getting my point. So it means two time. Anyway, let's see how it is going to work. Then CD and R2, as we discussed, just because of the cadmium is a metal, there is a positive charge and this is a negative charge. Okay, and again this is a R dash. Negatively charged, then how it is going to work? That negative part combine here. And now make sure this reaction we're going to discuss again and again. Right now I'm giving you a kind of mechanism, but otherwise, you know the what is the shortcut? It's combine here, this attack here, this chlorine leave. Don't worry, I will explain how the reaction is going to work. So again, that what will be the step there? It means this bond open up. What we are getting are CO, O negative. It's generated and it's a chlorine. And this R dash is connected here. Okay, again look at this, that O negative here, and as soon as the O negative came to the picture, chlorine is going to leave. As we discussed so many times, chlorine is a very good living group. Okay, then means what we are getting, that R, CO and R dash is there. It's a point number one. You can represent in a one step like this arrow move here, like this bond open up and a chlorine leave. But just for understanding purpose, since you're not familiar with the mechanism, so we can use mechanism like this. Okay, simple. And again, there is a one more cadmium is there. So that is combined. It means in this case, if you're observing that two molecule we have started, right? So it's a two there. It's a two there simply. And cadmium positively charged, cadmium two positive. So it's being like a counter end because there's a two negative charge present here. So this is a simple mechanism for the cadmium one. Okay. Now Let's see a kind of example. Mechanism, general reaction. Now let's see the example here. So how about the example? I'm using this CD plus C2H5 CO and Cl. So in this case, what we're getting that, okay, two time of this C2H5 and a CO and a CH3. It's a two times. This is the thing we are getting here. Okay, that's it. This is all for the reaction. Now let's see that same. Wait, actually, I have to explain, right? So in the preparation of the ketone part, the method number one from acyl chloride. From acyl chloride. And the same, the next method is from nitrile part. Like we discussed same in the aldehyde, same here. Acyl chloride, their Rosamond reaction, here that cadmium one. Then nitrile, that Stephen reaction, if you remember the dibyl H here. Same here, if let's suppose I'm having nitrile, then how to end up with the ketone. Okay, so let's discuss about the nitrile part. And in a nitrile part, if you want to convert a nitrile into the, okay, if I want to convert a nitrile into the ketone only, so then how to approach? Okay, so in this case, the reagent, you know which kind of reagent we are going to use. You know the reagent, you know the functioning of the reagent, but it's very much important because everyone we know that if I'm using CO bond, okay, and I'm using MZX, so it is going to work. But this one is a new method for you. It's important method again. So if let's suppose I'm using nitrile and I want to convert in the ketone, yes, I'm going to use the Grignard reagent. RMZX, dry ether, you know how it is going to work. That we are taking the Grignard reagent to the dry ether because the Grignard reagent also behaving like a acid base kind of reagent. It means first in organic chemistry, this is the rule. If we are having a choice for acid base reaction, so we can proceed elimination reaction, substitution reaction. Those are the secondary kind of reaction. You know what is the order there? First of all acid base, then elimination, then substitution, then pericyclic. Okay, so this is how the complete thing we are going to follow in organic chemistry. Anyway, it's not the point of discussion right now. So we are using Grignard reagent. And a step number two, like if you're using Grignard, so hydrolysis have to be there. Every time hydrolysis have to be there. So like you can use, let me just write, it's a two method that you can simply write water in H positive, the point number one, or you can simply use hydronium and both step represent hydrolysis. Now important is what? Reaction and mechanism. So let's just talk about the reaction. If I'm having R, carbon triple bond nitrogen, and then RMZX, as you already know how it is going to work, that it's a partial negative, it's a partial positive. Okay, and if in this bond you're observing something, that nitrogen is partially positive and sorry, carbon is partially positive, nitrogen is partially negative. It means it's really simple that my R part is going to combine with the carbon. Okay, and this is MZX. So MZX part is going to combine with the nitrogen. Okay, so just try to understand the basic rule. Like mechanism, obviously we are not going to apply every time in a paper. So all logical, R, carbon, and Mz with the nitrogen there. Okay, so it means that it's clearly you are observing something, that what is the thing I'm getting, that is a carbon double bond nitrogen. Okay, and this, let's see, this is R dash. Okay, this R dash connected here, and this MZB are going to connect here. Point, right? Normal. Now, the next step is what? Hydrolysis there. So what is happening in a hydrolysis part? That if we are to undergo the hydrolysis part here, so what is happening? That this bond break. Okay, this bond break and OH is going to combine here. Okay, so this, like you know, the water has a OH ion. Okay, and like this one has a plus ion. As you're observing something here, that on this carbon again we are getting a partial negative and positive charge. Okay, see this, that it's a partially negative. No, it's not visible. It's a partially positive. It's a partially negative. So which be like I can combine with the carbon, and hydrogen be like I can combine with the nitrogen. So in this case, what we are getting, that R CO double bond NOH and R dash. Okay, as you know that just because of the extra bond with the oxygen, hydrogen is going to leave there. Okay, so this hydrogen leave, and what we end up, we are end up with the ketone there. Okay, this is a general mechanism, like how the thing is going to work. It's a kind of shortcut. It's not the real mechanism. I will tell you the real mechanism in a while. So this is how the reaction look like. RCMX, carbon combined with the R part, combined with the MC part. And then at the end, we are getting a kind of ketone there. Okay, now let's talk about the mechanism, how the reaction is going to work, right? So, mechanism. Let's discuss about the mechanism part here. There is a some R, C, triple bond N, okay? And this is, let's say, the CH3. Okay, let's use some R with some kind of example. It's a CH3, okay? And this MCX we are using. Same, that it's a partially positive, it's a partially negative. It is combined here. This bond break, it's combined here, and this bond break. Okay, so it is a CH3, this carbon combined with the CH3 and a double bond nitrogen MgX. Okay, this thing we just discussed, right? So same. Now like we are using a kind of arrow, negative and a positive. Okay, now do you know what is it? It's a imine. It's a imine. If you remember that tautomerism, amine in amine kind of mechanism. Hello, Sudhay. So you're basically Indian, right? Or you're a native person of the Turkey then. Anyway, so what we're discussing, so this the carbon connected with the carbon there. So it's a imine. It's really important. Do you know sometimes which kind of question ask like some option is given to you. So like option be like, so we are getting imine, or the option number B, that is a SIP base. I guess you don't know about the SIP base right now, but both is a kind of same thing. Okay, so imine is important. Imine we are getting here. Okay, so that's it. This is a step number one. Imine formation take place. Like mechanism wise, maybe it's look very difficult for your calculatory, like actually what is going to happen. But again, mechanism part is not important here. Just try to understand. I already told you the shortcut. This is a kind of shortcut for you. Okay, but of course we are going to follow the mechanism as well. So let's see what is happening there, that we are using water now. So this is the water, that hydronium NH3, okay? It's a 2 negative. And this is a positively charged. So what is happening? Look at this. This nitrogen has a negative charge. This simply combined here. And this molecule leave. Okay? This molecule leave. And then what we are getting, the next step is this CH3, and this is a CH3, okay? And observe this hydrogen combine here, this hydrogen combine here, and this OH part, okay? Wait, I will explain how. This nitrogen combined with the hydrogen, okay? And see this, let me highlight this point, that magnesium part combined with this water, okay? It means with respect to this, we are getting that Mg, OH and X as well. Okay, this Mg part remove already. So this is the thing which we are discussing, that imine kind of thing. Now further, the reaction proceed after this step. We are getting this. Let's move further. How to proceed again. So it's a CH3 carbon nitrogen. Okay, like this and a CH3 there. Again, you know the water came to the picture, water and O. So every time the water molecule is playing a very important role. So nitrogen as a lone pair again, nitrogen simply combined here, and this again will leave. So what we are getting again, it's a CH3 and a carbon, okay, and the double bond and nitrogen combined with two hydrogen. Everyone, you know, when the nitrogen has a four kind of bond, so there's a positive charge present on a nitrogen, right? So then next is the CH3 there. And then what is happening again? Water came to the picture. You know what is the problem with the water? Water be like, I am going to leave, I am going to come. So again, water came to the picture. Water simply attack here, and this is how the bond open up again. Okay, so let's see the next step, that we are getting CH3, okay, carbon, This bond open now. This is NH2 now, and this is a CH3. And now water molecule combine like this. Again, again, what is happening there? Look at this. That we are having a double bond here. This hydrogen break the bond. Why? Because obviously the oxygen has a positive charge if you're observing positive charge. So what is happening? That look at this bond here. Ammonia will like you are, I'm having a lone pair. So it means ammonia going to abstract this hydrogen. Let me just explain like this. Okay. So this is how that ammonia going to take the hydrogen and water is like this. So means the next step is going to be that it's a CH3 and this nitrogen is combined with three hydrogen basically. Ammonia is ready. Ammonia will like, I'm going to leave now. So it's a CH3 and a OH is there. Right now we are getting this. Again, what will be the case here? That in this case, the oxygen has a lone pair, transfer here, ammonia going to leave. Okay, so like the water, now we are able to form successful ammonia. So let's see the step number two. Then what is the step number two? Sorry, I had to change the color. Okay, so look at this. What we are getting? It's a CH3 and a double bond OH is there and CH3, right? And that ammonia part automatically remove. And then again, just because of the positive charge on oxygen, the hydrogen leave the molecule. So what we are getting ketone there. So again, mechanism is just for understanding purpose here, not important. Try to understand just, okay? Let me just quickly give a brief. You're having Cn, this one is a partial negative, combine here, then we are observing this imine formation, MgOx remove, and the step number two, water come, and this is how the tag there, and then okay, like this, and this is the last point. I hope everyone you are able to understand this. Now, the thing which we have to remember, this is the single line statement. That partial negative charge on carbon, or like how the negative positive combine, and simply this is the only step we are going to remember. Because obviously in our exam we are not having that much time that we have to apply the mechanism. Okay, but just like for board exam, mechanism is important. Okay, this is only for the board exam. So yeah, you can see this. This is all for the mechanism. Now you're done. Any doubt with the step or any step not clear, please let me know. Okay, which one, Dashika? I guess I miss your chat. Which thing you're asking? Explain one more time. Yes, please. Okay then. So let's discuss about a kind of short trick. That's it. This is enough about the understanding point. Now let's discuss about the short trick. So how about the short trick? It's easy. So let's see again. This is my CH and a carbon triple bond nitrogen, and this is some CH3 and MgX. Okay, so basically that as we just discussed, carbon partial positive charge, nitrogen carbon partially negative charge. Okay, this one partially negative, this one partially positive. It means negative positive is going to combine, and it is a CH carbon part combined with the CH3 part. Okay, and a nitrogen part combined with the MgX part. Then water come. Okay, so what is happening? That after the water is there. So let me just write O. Wait a second. So look at this. This is my water and hydrogen there. So this part is going to combine with this. Okay. And see this how beautifully the reaction is there. That is, it's a CH3, CH3 and a carbon double bond O. Okay. And plus that is NH2 MgX is removed from the molecule. Okay, that's it. It's a kind of short trick. So we are going to remember only this point. Yeah, that's it. This is the reaction with the Grignard reagent for the formation of ketone only. Okay, where we used which question? Sorry, dipole H. Oh, I'm sorry. So let me just pack again. This is always very late. Okay, so let's just pack again. I guess you're asking about this question. No, 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 this is not this question. This question, right? Right, Dashika? Double H is important for the ester. If you're using ester, okay, so if you're using double H is a reducing agent. If I'm adding a double H into the ester, so then we are getting, that CH or aldehyde there. Okay, sorted? Okay, this is all for the ketone part. That again we're going to remember the trick only. Okay. Now let's all a question. Okay. Interesting. The organic question is every time interesting. So answer this question, please. So question is this. Take your time and then please answer the question properly. So it's not a difficult question. The same thing which we just discussed, we are going to apply. So it's a C2H5, okay, MZBr. And the step number two is the hydrolysis only. Like it's nothing, it's simple. We are again with the Grignard reagent kind of term in conditions, okay? And then there's a some A formation is there. And this A, I am using again that it's a CH3 MZBr one more time. Okay, and a step number two, that H2O there. Okay, so some B we are end up. Okay, in this case, Grignard reagent, then A, then in the A, again we're using Grignard reagent and we are end up with some B. And you have to identify that is the number of chiral carbon in B. So question is what? Number of chiral carbon, or better to use center, right? Because carbon may or may not be there. So chiral center in present in B. Okay, so options are like 4. Option B, it's a 4, okay? 3. C, it's a 5. D, it's a 2. Yes, please. What will be the correct answer? So some portion of the today's class and some portion of the previous class, right? It's CH3MCBr, okay? Yes, please. I guess question is easy, but still you're taking so much time. Hmm. What is this A? Same. Phobia with the chemistry, right? Organic chemistry, right? How to approach A, B, like how to, okay. So let me just explain the question. I don't know you're able to understand that. So let's start with the point number one. So in this case, what is it? Grignard reagent again. So target Grignard reagent. So Grignard reagent is either going to come in with the CO bond or a carbon triple bond nitrogen, right? We know the normal thing. Now see this. Yes, there is a CN group present. Yes, there's a Grignard reagent present. Then how it is going to work? Obviously, it's going to combine with the CN. And we just discuss about this that if you are using C2H5 and MZB are there, we just discuss about a kind of trick there that nitrogen combines with magnesium and the carbon combine with the CH2 there. Okay? And what up with the bond? Break this bond and put a double bond oxygen there. Okay, don't worry, I will explain on the next slide. Try to understand the thing. So, this, right, and a carbon, it is a CH3 and a carbon triple bond nitrogen. So in this case, you are using C2H5 and a Mz there, right? So let's apply the trick. It's a partially negative, it's a partially positive. Oh, sorry, Mz bar also there, okay? It's a partially negative and a partially positive. Let's quickly come by negative positive part. So I have to write that this is a C2H5 and this portion is combined with the MzBr there. Right? Step number one, that the Grignard reagent part. So after this, once we're getting this, let me just remove one bond. Sorted, right? The next step is the hydrolysis step. So if we are using a hydrolysis step, so water we are going to use, right? So let me just write again the water there. So in this case, this is O, hydrogen and a hydrogen there. So look at this, we just discussed whatever with the portion combine. Okay, and in this case look at this. Okay, so whatever the portion here, it's combined here like this. So it means in this case what will be that A, that a double C, it is a CH3 and a CO and a C2H5. Right now we are getting that what is this A there. So let's just pack again A. A. In the A, again we are using a Grignard reagent. Okay, so I hope you already know we discussed this thing already. If you are using a ketone, we are end up with a tertiary kind of alcohol, if you remember. So in this case, again, if I'm using one more time that MzBr or a CH3 there, so in this case, again, the same thing that look at this partially negative charge, partially positive charge, partially positive one, partially negative one. Again, what is happening? That obviously this Grignard reagent is going to connect. So in this case, let me explain here only. Okay? If I'm removing this bond here and how the magnesium part is going to combine, that one CH3 group connected here simply, and this is a O McBr again. And again, if you have to follow the hydrolysis portion here, then what we are getting? Okay, let me explain the hydrolysis portion on the next slide. If again that if we are to follow the hydrolysis, so it's a CH3, okay, it's a C2H5 and OH there. So this is RB. This is RB. Another question asked about that in B, how many chiral center? What is chiral center? The chiral center means that when a group is connected with four different group. So let's just search that this, let's start with this carbon, the carbon number one. So in this case, if you to observe, let's see the different group. Okay, so yeah, I'm observing CH3, one group, OH2 group, C2H5 three group, and this separate one is the fourth group. This is chiral. Yes, this is chiral carbon. So in this case, observe this is chiral carbon. So okay, mark it chiral carbon, the carbon number one. Okay then. Now, how about the second carbon? If I'm moving here, look at this carbon. Again, let's count. This is a separate group. It's a group number one. Oh, I missed the hydrogen. I'm really very sorry. So this is a hydrogen there. So look at this. Two group hydrogen CH3. Is this chiral? Yes, this is also the chiral. Two chiral center. Okay, two chiral center right now. Okay, similarly, let's move there. Look at this carbon, this carbon. So in this case, if you are observing that this side, it's a CH2 group. Yes, this side, that is, it's a CH2 group. But see, this CH2 is now connected with this. So it's counted as a separate group. So you can say the group number one, you can say the group number two, or you can say that one more hydrogen is there, that group number three, and this giant one is the group number 4. So all group are different. Yes, it's chiral. Yes, the chiral carbon. So let me just erase one more time, and it means this is also the chiral center. Yes, this is also the chiral center. So let's just see. It's a chiral center. Okay then. This is not going to be the chiral because of two hydrogen. Again, not chiral, two hydrogen. Again, not chiral because of two hydrogen. Because two different, two same group, so it means not. Now, see this. We are just left with only one portion here. Okay, look at this. So one more is the CH3 group. Okay, sorted. One is the hydrogen 2 group. Yes. Now look at this. If you're observing this side, CH2, CH2. Okay, there's a tie. And look at this. It's a CH2. If there's a tie for the first carbon, we're moving toward the second. So observe this. The second one, CH2 is there. Okay. It's a CH2. So it's a CH2 there. But if the same thing, if the same number of carbon, let me just count. With respect to this, it's a point number one, it's a point number two. Same here, it's a point number one, it's a point number two. See, the second is different, totally different. Is this chiral? Yes, this is also the chiral center. Okay, so it means this is also the chiral one. Okay, I'm erasing now. Okay. So let's just see one more chiral center. This is the chiral center. Total how many? If you're to highlight, one chiral, two chiral, three chiral, and a four chiral is there. So total four chiral center present in this given compound. So what will be the final answer? That answer for this question is going to be the option number A. Okay, option number A. Four is the correct answer. Now your turn. Any problem? Okay. No, no, listen. Listen, Dashika. If there's a tie for the carbon number one, then we have to go with the carbon number two. For example, let me explain how. Let's just suppose, okay, this is a kind of molecule, okay, and there's just some double bond connected. And let me just connect a kind of hydrogen there, okay, Dashika. Look at this. So in this case, this is a group number one, a different group, okay, hydrogen group number two, okay, two group different. Now let's just first suppose the third one. So if you have to observe, this is the same. It's a CH2 and it is a CH2. I guess it's not visible. Okay, it is a CH2 and this is also the CH2. Time the carbon number one. Let's move further. Let's move one carbon here and move one carbon here. Okay, so look at this here that this carbon has a double bond, but this carbon has a single bond. So you can say this environment and this environment is different. So I'm not saying group have to be different. It means the environment have to be different. Okay, like first atom is carbon, or maybe the same carbon connected with chlorine, or maybe the different carbon connected with the bromine. Are you getting the Shika that why this is a chiral one? So four different environment have to be there. I'm not saying atom, group or environment. Environment is the better one. Okay then. So if you're observing toward the question one more time, see this. That look at this with respect to this center. If you're observing three carbon, that some this group come right. This complete group came into the picture. But on the other hand, if you to move two dot there, so nothing is present here. So yes, different environment. Okay, Dishika, is this point clear? But four is the correct answer. Okay, that's it. This is all for the question and this is all for the class as well. Now your turn. Any problem? Okay, please ask. So this is all for the preparation. In the next class, we will continue about the same thing that the preparation of ketone only. Okay, because only two method we discuss, right? The cadmium one and the second was the Grignard one. Yes, please. Any doubt or any problem? Yes. Yes, please. Any doubt or shall we end the class then? Okay then. So thank you so much. Okay. Thank you so much then everyone for joining the class. Have a nice day everyone and thank you so much.